Alright, so today we're going to be doing vertical asymptotes and holes, but what we need to start with is what is an asymptote. So, an asymptote is a line that a graph approaches, but it never touches it. Okay, so now that we know an asymptote is a line that a graph approaches but never touches, we can see what it looks like graphically. So if you look here, the graph is going along its merry way, but then you have to, if you were tracing this with your pencil, you would have to pick up your pencil to go to the next part of the graph. So that's how you know that there's a discontinuity here. And you can see that these two ends are approaching a vertical line. So this is going to be your vertical asymptote, that vertical line that the graph is going as close as it possibly can to, but never touching it. So here's one vertical asymptote, here is another vertical asymptote. They're not going to appear on your graph as dotted lines, but you would be able to draw a dotted line connecting both the ends here. So this graph has vertical asymptotes, which I usually write as VA, at x equals -5. So if we go here, 1, 2, 3, 4, 5, and x equals 2, 1, 2. We always write these as x values because they're going through ticks on the x-axis. These lines are. Okay, so now let's look algebraically. All right, algebraically, if you had something factored, if you have factors on the bottom, then your vertical asymptotes are going to come from what makes these bottom factors 0. Okay, so what makes the bottom 0 here is +3. If I plugged in a +3 right here, I would get 0. So one vertical asymptote is at +3. And the other vertical asymptote, looking here, -5 plus 5 is 0. So since -5 is what makes this bottom 0, then it's going to be at x equals -5. All right, let's move on to another discontinuity. Okay, we're going to look at holes. So what is a hole? Instead of a line that a graph never touches, this is going to be a point that a graph never touches. Okay, and holes and vertical asymptotes are both called discontinuities. So I'm just going to write that word here. Discontinuity. Okay, so now that we know that these are discontinuities, let's look at what this looks like graphically and then algebraically. So graphically, it'd be like if you had a function that was coming like this, and then there was a place where it just would never existed. So at this point, the graph is coming, and then it sort of jumps over that little point and keeps going. But you can get as close to that point as you want to, as long as you don't touch it. So here, the hole is at x equals -3. 1, 2, 3. And we're going to write this as an x value, just like we wrote the vertical asymptote as an x value. So let's look at what it looks like algebraically. If you had a function that was fully factored, then your hole is going to be where something cancels out on the top and bottom. So if you look here, these x plus 2's are going to cancel out, but we're going to do the same thing that we did on the top one and ask ourselves, what makes this 0? So what's going to make this 0 is if I plug in a -2 right here. -2 plus 2 is 0, same thing here. So the hole is going to be at -2, but it's that place where the factors crossed out on the top and the bottom. And then just for practice, the vertical asymptote is not -2, okay? This is a hole. The vertical asymptote is going to be a factor that's left on the bottom. So notice this x is by itself on the bottom. What would make this 0 is simply x equals 0, okay? So the thing that did not cancel out is your vertical asymptote, and the other one that did cancel out is your hole, okay? So let's look at some examples. Okay, for these, I want you to just find all the vertical asymptotes and all the holes. So starting here, what we're going to do is we're going to factor this. Okay, so the first thing that you want to do in any factoring is ask yourself if there's anything these two terms have in common. Here, yes, they do. 48 is divisible by 3, so we're going to go ahead and pull out the -3. And we're going to have x squared, let me zoom in, minus 16. And then on the bottom, we're going to have to do our headphones. Luckily, there's a 1 in front of the x squared. We're going to do 1 times -4, which is -4. And we want 2 factors of -4 that add to give you -3. So that's the number in the middle here. Okay, factors of 4 are 2 and 2 and 1 and 4. So we're going to use 1 and 4 to get to -3. We're going to do -4 and +1 to get to -3. So taking our shortcut, since there was a 1 in the front, we're going to have x minus 4 times x plus 1 on the bottom. But before we continue, this x squared minus 16 is actually a difference of squares, so we can factor this. If you're having problems with factoring, you can go back to the very first video of this unit, Unit 6, Day 1, it will help you out. So we have -3. The difference of squares is x squared minus 4 squared. So this is going to be x plus 4 times x minus 4. And then on the bottom, we're just going to leave our other factors. Okay, so hopefully now you can see that there's an x minus 4 on top and bottom. This is going to be your whole, but remember, it's what makes that 0. So here we have a whole at x equals +4, because if I put in +4, you get 4 minus 4, which is 0. And we have a vertical asymptote at the other factor that's left on the bottom. So what makes this 0 is going to be -1. -1 plus 1 is 0. So the vertical asymptote is that x equals -1. And we're done with this problem. But let me show you what this looks like in Desmos. You might like that way better than the factoring. Personally, I like the factoring, but let's go to Desmos. All right, I have this function typed in up top. If you look at this graphically, you can see that this does have vertical asymptote. If I were tracing it, I'd have to pick up my pencil to go to the other part. So let me show you that this is at x equals -1. Okay, this is my vertical asymptote. This is the line that is approaching but never touching. So we got that part right. And then the other thing is the whole that is supposed to be at x equals 4. You can check your whole by seeing if at 4 on the graph, there is a hole there. So if you look right here, there. Okay, so at 4, it is undefined. Remember, this is the x value of 4. And you can actually see the open hole on Desmos. So this is a way of checking. It's really hard to find the hole if you don't know where it is. So you're going to have to probably do the whole part algebraically. Okay, let's look at another example. We're going to be factoring again. So there's a 1 in front of this x squared. 1 times -8 is -8. And we want 2 factors of -8 that add to give us +2. So factors of 8 are 1 and 8 and 2 and 4. So we're going to use 4 and -2 to get to +2. So this is equal to x plus 4 times x minus 2. And then on the bottom, we're going to factor this as well. And each of these terms have an x in it. So we're going to pull out an x, and we're going to be left with x minus 2. Okay, now we can see that the x minus 2's cancel out. So that is going to be our whole. Okay, so we have a whole at x equals 2. Remember, it's the opposite of that number. And then a vertical asymptote at this one that's left over. What would make this 0 is just x equals 0. So this is x equals 0. All right, and let me just show you graphically. So this one, I also have it typed in. Our vertical asymptote was at x equals 0. And you can see that this is the line that it's approaching but never touching. And then it has a hole at 2. So let's check and see if it's at 2, which is right here. There it is. Okay, so you can see that there is indeed a hole at 2. Yeah, there it is. Okay, so let's go to our example number 3. Oh, and let me show you on the table as well. At 2, it should say undefined, and it should also say undefined at 0. So here, if I click on the table, at 0, it's undefined. That's your vertical asymptote. And at 2, it's undefined. So these are your discontinuities. Here's your vertical asymptote, and here's your hole. So let's do example number 3, and we'll be done. All right, last example. Again, we're going to factor the top and bottom, and then see what cancels out. So there's a 1 in front of the x squared, so we're going to do 1 times negative 12, which is negative 12. And then we want 2 factors of negative 12 to add to give us positive 1, because there's a 1 in front of that x. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So we're going to use positive 4 and negative 3 to get to positive 1. So that means that this is factored as x plus 4 times x minus 3. And then on the bottom, I can pull out a negative 2, and I'm going to be left with x plus 2. All right, so notice here, nothing cancels out at all. So that means we have no, you guessed it, no holes. Okay, so there's no holes here. You can just put none, you can put NA, whatever you like to write. I like none for this case. And then we're going to look and see what factors are left over on the bottom and see what make those 0. So the number negative 2 can never be 0, so we're not going to mess with that at all. But looking here, this is your factor where you can plug in something that would make it 0. So if I plugged in negative 2 right here, I would get 0. So that's my vertical asymptote there. So there's a vertical asymptote at x equals negative 2. All right, and let's just look back at the graph if that's the type of thing you like. So looking here, let me turn this graph. You should have a vertical asymptote at x equals negative 2. Okay, so looking here, you can tell that that is the line it's approaching but never touching. Sometimes you can just kind of see it, sometimes not. And then the hole, there would never be a hole here. So even if you kept checking, you would never find anything that was a hole. All right, hope you guys enjoyed this video. Please let me know if you have any questions at all. Have a great day. Stay safe. Take care of yourselves out there. Bye.